guys, welcome back to A-Level Lessons Online. Alright, we're back with our Physical Geog series. Moving on to this next part on cyclones. This video we're going to be looking at the pattern of occurrence of cyclones, okay, as well as the conditions of factors that affect cyclones. So how do cyclones even come about, and how do they even form? So firstly, let's go through the definition of tropical cyclones. Right, we're looking at tropical cyclones. So we're not going to be looking at cyclones that occur in your higher latitude areas, or that in areas that are outside of the tropics. Okay, we're looking just specifically within the tropics, cyclones that can occur as a result of tropical characteristics, right? Be it your humid tropics or your arid tropics. So tropical cyclones are basically large thunderstorm complexes rotating around an area of low pressure. So they are always known as low pressure areas, right? Or low pressure cyclones. And we will see why they require low pressure later on. They have formed over warm tropical or subtropical ocean water. So basically, like we have gone through before in our Haley cell video, when the temperature is high, it means that the pressure is low, right? And likewise vice versa. Okay, high pressure usually is brought about by lower temperatures. So when there is an area of warm, right, meaning to say that there is higher temperatures of water, a water body, okay, it makes it more favorable to actually form this region of low pressure, which can allow tropical cyclones to form. So they're also known as hurricanes or typhoons. For those of you guys who have heard these other terms before, there is no difference. So if you ever see it in your exams, you can just take note that they are basically the same thing. So how does a cyclone actually evolve, right? How does it start? What does it start as? And how does it actually end? So most tropical cyclones, okay, they always start as a small scale disturbance. So we'll see the four stages later on. And then due to intense convection activity, right, like we've learned in the tropics, right, there is usually high annual temperatures. Okay, and this leads to regions of low pressure that can form over water bodies. So when there is high or intense convection activities, okay, your cumulonimbus clouds will actually form. And due to your Coriolis effect, okay, when accompanied by the higher temperatures in your water bodies and the area of low pressure, okay, will actually enlarge into these rotating wind systems, which are known as your cyclones. So end of the day, tropical cyclones, they form because of areas of low pressure that is caused by your, it all always boils back to your macro factor, which is the Haley cell, right, which has got ITCZ, STHP. So when there's intense convection activity, there's areas of high temperature, it would actually cause low pressure to be more prevalent, especially over water bodies, and due to your Coriolis effect, it forms that spinning effect that actually causes a cyclone to form in the first place. So it starts off as a disturbance usually, and then it goes on to a depression, okay, whereby it's basically a bigger version of this rotating wind system, followed by a storm, right, whereby there's a lot of water as well that's involved, okay, a lot of rainfall, thunderstorms, and lastly, tropical cyclone. So this is the full form effect when it can go up to very, very high speeds, right, and it can rotate very fast, and has a lot of water, a lot of moisture that it carries as well, with the ability to bring about rainfall to certain areas, especially those that are nearer the coastal areas of wherever the cyclone has formed. So this is how the structure looks like. Okay, it's good to know how the structure looks like in the event that you may need to draw or annotate a diagram. Oops, don't mind that. And so essentially, this is how a tropical cyclone will look like. Basically, it has got all these rain bands, right, that you see over here, right? These rain bands, okay, they are basically where the moisture is being picked up. Okay, so usually cyclones, they start off when there is rising air. Okay, when there is there's this middle part over here, you see over here, which is known as the eye. So what happens is that there is basically the Coriolis effect that is taking place in here, whereby on the outside there are all these warm air that are rising. We also call these the eye walls, right? And what happens is that depending on the Coriolis effect, right, be it in the north or south, the cyclone will rotate accordingly to the Coriolis effect. So what happens is that when there's the warming air which rises, okay, the warming air would actually go into the eye and it would start to go upwards, right? And as we know, hot air rises, cold air sinks, so there will also be sinking air that takes place in the eye. And what happens is that it will start to enlarge, okay, as it moves up, okay, alongside the rain bands. So all this is all happening simultaneously, right? There's also going to be rain that's being brought about, and then it would continue to flow and flow. And in this case, the air that actually goes into the middle of the eye would then continue to rotate and rotate. In this case, it outflows anti-clockwise, opposite from the direction of the cyclone, right? Which is why if you look at a cyclone, you notice that it has a very, very funny shape. It is as though it's going anti-clockwise but at the same time going clockwise. Reason being, okay, is that the outflow in terms of the air, which is actually rising, okay, is actually going opposite from the direction of the rotation of the cyclone. Right? Think of it like the wheels of a car, right? In the sense of in which the direction goes, right? There's always that opposing force that is also involved when the car turns, for example. So likewise in this case, this is how the structure basically looks like in the case of the southern hemisphere. So southern hemisphere, which is why our outflow is anti-clockwise and our cyclone rotation is going to be clockwise. So this is just an example. Okay, in the event you need to draw it, okay, just be mindful of the few different things you need to draw. Mainly your eye walls. So these are going to be the eye walls. Alright. And we're going to be drawing all of these parts as well. So that where the warm air rises. And then draw the eye. So the eye is the middle part over here, where the air, warm air, will rise. And then there will also be air which actually sinks, because like we've said, hot air rises, cold air sinks. So this is how it will form. Okay, basically the ocean will be somewhere below the cyclone. So this is roughly how the structure of a cyclone is supposed to look like. Alright, so what are the factors that influence the formation of tropical cyclones? So firstly, it needs to be a location over the ocean with surface temperatures more than 27 degrees Celsius. Reason being is that high temperatures are required for the initial heat energy to actually kickstart the convectional activity within that area. Right, what happens is that when there is high temperatures, it would actually cause it to be favorable in terms of creating a region of low pressure. Right, and not only that, okay, there will be a high rate of evaporation as well as condensation, and this releases latent heat, okay, or latent into the atmosphere, and it makes the air lighter. Okay, and this will cause the surface low to strengthen, and hence making the moisture flow into the system simpler. Right, what happens is that when there is high temperatures, right, there's a region of low pressure, it starts to kickstart the formation of a disturbance. Right, and when it kickstarts this formation of a disturbance, it would then continue to actually have, like we've said, right, the rising air is warm, the cooling air is also sinking at the same time, so it causes condensation to occur, and this would cause the air to become lighter, hence allowing for moisture, those rain bands, to actually form. So not only that, there's also intense convection activity that happens, so this will form cumulonimbus clouds as well, which can all basically be a whole part of the entire cyclone, right, which can bring about the rainfall. And lastly, also a friction-free surface. This will allow for continuous supply of warm, moist air to actually occur. Right, when there's no friction, the warm air or the warm, moist air per se can actually continue to be supplied to the entire tropical cyclone, to the eye of the storm, or eye of the cyclone. Next thing, it has to be a location over 5 to 2 degrees north and south of the equator. Reason being is for the Coriolis force, right? One thing that is characteristic of a cyclone is the fact that it can rotate, right? It's kind of like think of it like a tornado, right? It's like rotating as it's moving around. So Coriolis force is the one effect that, or the one force that can actually cause this rotation to occur, right? It causes the winds to be deflected, your trade winds to be deflected. Likewise, it will cause the entire cyclone to be rotated around depending on which side of the hemisphere it is in. Right, so it helps the wind spiral inwards towards the low pressure center. Next one will be the presence of an upper atmosphere air rotation. Okay, some people call it an anticyclone in the upper troposphere. So this is basically above the actual cyclone that is being formed. So this actually stops rising air from advancing and allows air to draw outwards of the system at the top. So think of it like an anticyclone. It's like a barrier that is being formed above the cyclone itself. So this would help okay, to sustain the air circulation within the low pressure area and continue to intensify and grow it in size to become an actual cyclone. So it's kind of like think of it like a box. Right above the box there is a lid. So as the cyclone is actually forming, right, you've got all your rain bands, you've got the eye that's forming, okay, the air is pushing it upwards, it reaches this lid where it cannot get out of this lid, which is known as your anticyclone. And as a result of that, okay, the air would actually be pushed backwards where it meets with the moist and warm air, right, because this air that's up here becomes cooler already, and this would cause it to meet and cause condensation to form, resulting in more rain bands to form and an overall bigger cyclone that is actually going to occur as a result of it being so concentrated, right? All your air is basically being forced down below, so it pushes the entire cyclone outwards, causes it to expand, and think of it like the box that's being expanded as a result of continuous supply of air that is basically going inside. So this is one of the illustrations that I can give you. Hopefully you can visualize from it. If you are still unsure, you can just leave a comment in the description below, a question, and I will answer it for you. Alright, so the last one will be the absence of a vertical wind shear with altitude. So small wind speed and direction changes with altitude is needed, right, to maintain the maximum convection activity to ensure that the heat is continually supplied. And for your cloud development, your cumulonimbus cloud development over the region of low pressure. So that is what a vertical wind shear does with at altitude. Okay, when it is actually there, it actually prevents any sort of wind speed changes and directional changes, which is why it cannot be there. Okay, with altitude. Okay, so that your heat that is being supplied to the cyclone, for it to form more clouds, for it to form more rain bands, right, can actually continually be supplied. So that is the reason why there has to be the absence of a vertical wind shear with altitude. So the higher we go. Alright, so that's actually all of your factors that actually affect a cyclone. That is something that you have to know. So you have to be able to explain your exam requirements, explain the factors that influence the formation of a tropical cyclone, as well as to describe and explain the pattern of occurrence or development of a tropical cyclone. Essentially, how it goes from a disturbance on towards a cyclone, the 4 different stages, right? And all in all, this chapter, make sure you understand and you grasp the basic 4 different factors. For example, your the amount of heat you have, the anticyclone, the absence of a vertical wind shear, your Coriolis effect. Right? These are the main factors that actually cause a cyclone to form, and it is what is characteristic of a cyclone. Without the Coriolis force, for example, the cyclone won't spin, it won't rotate. That means that it's basically just a huge cumulonimbus cloud, or it's just a huge area of huge amounts of warm air, which is not a cyclone. So a cyclone is only a cyclone if it rotates and it moves towards the low pressure center. That is what a cyclone is. So that's why we need the Coriolis force, for example. Right, so go and study the other factors. Okay, if you have any questions and you're still unsure on anything, I know this can be a bit tricky. Cyclones is not the easiest part of your syllabus to master. So if you have any questions, you can leave it in the comment section below and I will clarify it. I may even do a second part, okay, to go into greater details on everything about cyclones. Okay, for example, what is a disturbance, what is a storm, what is a cyclone itself. But this is basically the main parts or the main stuff that you need to know when it comes to your exam. So make sure you master it, and if you did learn something or you did enjoy this video, be sure to give it a like, as well as to subscribe to the channel. It's free, it doesn't cost you anything, and you can always change your mind later on. If not, that is all I have for you guys. I will see you guys in the next part. Have a good one. Bye bye.